Good morning, Dallas. Good evening, India. Good evening, Bangalore, and that is in India. And and good afternoon and good evening to all the people who are watching this show from wherever you are. And today's Friday show, talk show, is with a special guest from India in Bangalore city. However, we will mention about that guest in a very few minutes. Before that, I want to welcome all of you to this Friday talk show with your host Rajiv Kulkarni. Every Friday, we bring a different guest from a different field, but definitely concerning to the electronics manufacturing activity. So we talk about the electronics manufacturing challenges, we talk about the conditions engaged in the electronics manufacturing, we talk about the application side, we talk about various other activities that pertains to electronics manufacturing. And this is a very simple and very straightforward channel which is meant to give technology sharing to all the people, to all the engineers who definitely can make use of it. With that said, I want to thank all the supporters who are supporting the channel, like yourself, who are watching the channel, who are watching our show on a regular basis and subscribe the channel. The more the subscribers, the more the viewers, the more the viewership is, our guest is happy and we are also very happy. So let's not take too much time of yours. Let me introduce briefly about the theme of the subject today. This is embedded design and development in electronics manufacturing. Embedded design and development refers to the process of designing and developing specialized computer systems that are embedded within a larger device or system. These systems are typically designed to perform a specific function or set of functions and are often used in applications such as consumer electronics, industrial control systems, medical devices, automotive, and so on and so forth. So, what are the key aspects? What are the design consideration? What kind of platforms these embedded systems are used? And we have several these kind of questions, in the industry. And we have a very, I would say, a young gentleman from Silicon Valley of India, that is Bangalore, India, who is a co-founder of a company called GIPZONIcs Technolabs. I think I spelt it correctly, but we will hear from him only. And Mr. Vinay Hegde, he is an engineer and he is an experienced engineer, I would say, in the embedded design and systems. Welcome to the show, Vinay. Good evening to you. How are you this evening? You can unmute the audio.
Very good evening, Rajiv. I'm doing good. How are you doing?
I'm doing great. Thank you very much. Thank you for asking. Thank you very much for joining the show. I know that being the co-founder, being the operation in charge of the company, it's not an easy thing to come to the show on a Friday evening, which is a busy, busy, busy evening, and because either you are getting ready for the weekend or you are getting home so that you are ready again to go to work tomorrow on Saturday. Because in many countries, people work on Saturday as well. And I know in India, most of the companies, they do work on Saturdays. So thank you again for joining the show and willing to share whatever knowledge you have in the embedded design and and development for the electronics manufacturing. So first of all, introduce, give us some input about yourself, Vinay. Originally, where are you from and how long you have been in this business and so on and so forth.
My name is Vinay Hegde, and I'm basically from Sirsi, North Canara district in Karnataka. I did my bachelor's of engineering from Acharya Pathshala College of Engineering, Bangalore, and
Okay.
started to work in a company as a business analyst prior to starting this company. we are like group of people who wanted to bring the technology to the common man or provide the best technological service at affordable prices.
Okay, great.
We started it
So
in 2015.
2015. Okay.
Yes, it's almost 10 years old company.
10 years. Excellent. So that's a 10th year celebration, I think, I would say. And
Yes.
we are very happy to celebrate that with you in 2025. And we are fortunate enough to have you on Global Electronics. That's great. That is great. So,
Sorry.
Vinay, yeah, Vinay, tell us about what exactly is embedded design and development means.
As you said earlier, embedded systems are specialized computer systems,
Okay.
basically a microcontroller designed for specific task. It is
Okay.
like controllers will have multiple tasks like your processors or FPGAs. It will do a particular task in a larger system. Consider a washing machine where it will have multiple microcontrollers for controlling different jobs. For
Okay.
example, controller for setting the timer, another controller for rotating the motor. Like this, there will be different controllers many times.
Okay.
It is like the purpose of microcontroller is it will not process any data. It is just like data acquisition, comparing, and decision taking. Or
Oh,
sometimes
okay.
it will read the input and take the decisions. That's it. Even basically, you can consider basic example of the embedded systems is your temperature gun, which we use on a daily basis at household for measuring temperatures. So that is a simple example of embedded system. Just take the device, turn it on, keep it under your shoulder, and after some time it will give you a beep and it will show the reading. It is simple example of embedded systems that will have a microcontroller and a temperature sensor. So
Okay.
when you keep inside the underarm for particular time duration, which is programmed maybe 10 seconds or 15 seconds, it will continuously read the temperature data. And
Okay.
once the reading is stabilized, or when it reaches a saturation, so that there will be no further fluctuation in the temperature, it will consider that and it will show it on the display. This is basic microcontroller.
Okay, great, great. That is very simple way to understand from for a common person. Even though he is an engineer, still embedded means it's a very, I would say, fancy word, in the engineering world, So, but yeah, very easy way. You made it very easy to make us all understand. That's great. So I know that you mentioned you started your company 10 years back. How did it all begin?
In 2015, like from many days, I have we are total three co-founders. One is me, and another one is Mr. Girish, and another one is Mr. Anup. We were engineering classmates. We
Okay.
previously had idea of starting a business. We did not have the clarity like how to proceed, what to do. None of us from business background. We are first generation entrepreneurs. So we had thought from very long time. So we during our college days we used to do the academic projects.
Okay.
So like when people started buying the project from us, we got the confidence that one thing we can do the coding and we can execute the project successfully, and second thing we can sell it too. Because building product is one thing and selling it is a completely different story.
Yeah.
So we got that confidence after working for a couple of years. We thought to pursue a dream, and we started it in 2015.
Okay.
Initially, we used to meet the startup ecosystem like incubators, startup tech meets, community meetups, or aspiring entrepreneurs. We used to meet them to learn about their ideas. Slowly we started building the prototypes for them. Like we had the collaboration with the design houses like industrial designers. startup incubators.
Okay.
Some of the electronics shops in SP Road, we had good connections with them. So initially, we used to get the projects from these places, very, very small embedded based projects. So after a couple of years, after a couple of years, we started approaching the industries for their industrial requirements.
Hmm.
So presently, we are working with global healthcare giants like GE Healthcare, Siemens Healthineers, Baxter Innovations, Vantive Healthcare, Cregna Medicals,
Wow,
to name.
that's great. I think that's a great achievement. And like, how many engineers work with you right now?
Like full time, we are 11 people.
Okay.
And as we are a small firm, we have contract with manufacturing and
Sure.
other industries where we
Yeah.
outsource the PCB manufacturing and assembly process.
Correct. Okay.
Design testing will be done at our premises.
Okay. Great. Great. So, what are the actual key aspects of embedded systems? You know.
Embedded systems, Rajiv, is a very vast thing. In every day-to-day life, we encounter
Yeah.
many embedded system devices. Keep it, maybe your fridge, your washing machine, or your a microwave, or your car, or your mobile phone. There are so many things, but we have to distinguish distinguish the controllers used there. In the simple devices like washing machine or microwaves, very small controller with small capabilities are used. In rockets or in high-speed devices, there are different sets of microcontrollers depending on their speed or decision-taking abilities or processing power or memory. So there are few key aspects, which I'm going to tell you in next 5 minutes.
Sure.
First is the real-time performance. The job of the microcontroller is to respond very quickly when the event happens. Within the time constraint, they have to operate. This is the very primary requirement or aspect of the embedded system.
Embedded
Second thing
system.
is the resource constraints. So embedded system is a very small device or it is made up of very small microcontrollers. Here the challenges are memory is a major challenge. We can't write a code which is a 20 page or 50 page like we do write the programs in for our softwares, maybe a desktop software or a software running in the server or etc. So the memory is limited in the microcontrollers or embedded systems. You have to write very short codes and very efficiently it should work. So memory is the major constraint.
Okay.
The power consumption, especially for the battery powered devices. Imagine you are using a TV remote controller. Just imagine your situation when it asks you to replace the battery every 1 week. That is practically very difficult, right?
Yeah.
So you should power consumption should be very low. It depends on the application to application. For a washing machine or the TV, when that works on the live power, it doesn't require the memory management. But the controllers, like the devices like a remote controller or your mobile phone, the power consumption is a major aspect.
Okay.
And processing power. For smaller devices, processing power will be very less. Imagine just measuring the temperature or your burglar alarm, where it will be connected to a sensor, and when there is an intruder, it will give you a loud alarm. So that is it requires very small processing power. Just read one data from the sensor and one output from and give one output to the siren. Here the processing power is not required. But when you are going for a larger application like Internet of Things or industrial automation, you need more processing power. When you are connecting different kind of sensor with 2K data reading, 2 kilobytes of data coming from different sensors, and processing those data will be very difficult.
Difficult,
Maybe
yeah.
you might be monitoring a vibration or temperature or any parameter from a industrial environment. So in that case, in that scenarios, you need a faster processing power.
Okay, okay.
And next one very important is form factor or the size. As I said earlier, microcontroller is not the complete system. It is a part of system. So when we are
Right.
building a larger system, we have to think about the form factor or size of the microcontroller board we are placing. We can't place a very big circuit on top of a washing machine or on top of a microwave oven. It should be very tiny, consuming very less space. For
Right.
form factor, there is a famous, like very famous argument between the industrial designers and the embedded designers. For embedded system developers, they think that the microcontroller, its functionality is the major product, but industrial designers thinks that the outer feel, outer look, or the presentation is a major design concept. So there is always conflict between these two people. So form factor plays a major role.
Sure. Okay, that's a wonderful thing. Let's take a quick 45 seconds break and we'll be back.
Sure.
Good morning, good afternoon, good evening. Welcome to the Friday Talk Show with Rajiv Kulkarni on Global Electronics channel. And this channel is meant to bring the expertise from the industry on various fields in the electronics manufacturing segment, so that everybody gets fair, some knowledge sharing kind of activities. So people come here on this platform and share the knowledge in their expertise field. And today's topic is embedded design and the development in the electronics manufacturing. And we have a special guest from Bangalore, which is the Silicon Valley of India, Mr. Vinay Hegde, who is one of the co-founder of a company called GoZips. Uh, Zip. Oh, I'm sorry, I forgot the company name. I'm messing it up because it's so hard, the company name itself. So, but anyway, zipzonics.com. If you want to know more about them, zipzonics.com. That is GIPZ, that is Z in India, they call zonics.com, zipzonics.com. He is one of the co-founder of the company. Vinay, welcome back after this small break, and let's continue with our
Thank you.
knowledge sharing talks. Sorry to mess up your company name a little bit,
That's okay.
because I've been practicing very hard to remember the name, but every time I got it wrong, and sorry about that. So we spoke about what is embedded design and development. We spoke about your company. We spoke about what are the key aspects of embedded system. Now, what are the key consideration for embedded systems?
Uh, Key consideration is like cost is the key consideration if you ask me.
Okay,
Uh, because uh, 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 the as it is a part of the system, the user will not be ready to invest so much on the embedded part. Either
okay,
it might be your smart TV or it might be any application. Even in the defense, surface to air missiles have the embedded system. So people will not afford to have a expensive hardware or expensive embedded system mounted to be mounted on their devices. So it's effective should cost effectiveness should be there in the embedded system devices, and reliability and stability should be there. These are the three factors which we consider while designing a embedded system for any application, very small to very large applications.
Okay, that's a very smart answer. And what are the main tools involved in the embedded systems?
Embedded is a very vast
Yeah.
subject. People use different controllers and different environments for different kind of development. For very small projects, you can go for Arduino. Little bit higher level like industrial automation kind of thing, you can go for the PIC microcontrollers. For
Mm-hmm.
developing the Arduino code, you can use the Arduino IDE. For developing the industrial projects, you can use the PIC microcontrollers, and the IDE is called as EMC Lab. There are different players in the market for in the embedded system domain who manufacture different kinds of microcontrollers with different specifications. So it
Okay.
depends on the application. We choose the different controllers. Maybe for very small toys or something, we can go for Arduino, or industrial automations. You can go for PIC microcontrollers, which is from TI. If there is any high level of data processing or data reading, then you can go for the ARM controllers. If there is any data processing required, then you can go for the Raspberry Pi or any other processors which are open source. You can write your own code.
Okay.
Uh, for automotive grade, you can use the Renesas. For medical application, you can go for the STM microcontroller. It purely depends on the budget and the application you are building. It totally
Okay.
depends.
Okay, great. And
Controllers have their own, every manufacturer have their own development environments tools for coding their controllers. There is no
excellent.
universal one-stop coding solution for this thing.
Because it keeps changing depending on the design aspect, depending on the customer's requirement, and so based on that, people will choose for different tools
Correct.
depending on their need of the customer's end. Okay, yeah, that's quite it makes sense for sure. And now one more question is, what are the common main platforms on the embedded designs?
Like we mainly focus on microcontroller part. We
Okay.
do take less projects on SoC or FPGA part. We mainly focus on microcontroller part. So
Okay.
basically, we started with the 8051 architecture. That is a very old, around 40 years old architecture it is. They have different microcontroller family, but it is like a wine. When it is old, it's like a old wine. It still works very good. We have many controllers from this architecture, so we work on that. And Arduino is there. Arduino is for quick prototyping. If you want to build something and test something very quickly, maybe within 2 3 days, then you can use the Arduino platform for building your product. Maybe some school projects or some small industrial automation projects also you can build using the Arduino family. That is very easy to code and dump. Very like even codes are very easy to write, easy to dump the code into the controller, and you will get a lot of community support from all over the globe. The Arduino community is very huge community. You will get almost all programs will be available in the internet. You just need to know the basics, like what are the digital IOs, what are the analog IOs, what is the DAC, what is ADC, what is the processor speed, what is the controller speed, like at a time
Wow.
how controllers data pins can be read. If you know all these basic details, like anybody can use the Arduino platform and develop their code, their
System.
first embedded system.
So
And
now, yeah, go
yes,
ahead, please. Please go ahead.
now we have one more STM microcontrollers. They are very industrial standard, and they are not prone. These Arduino controllers are prone to electromagnetic noises, but this PIC and STM controllers are, they are not prone to electromagnetic noise. These are very specifically used for industrial automations, where we'll get a lot of surges, a lot of electromagnetic interference from adjacent motors or adjacent devices. So for these kind of environments, PIC microcontrollers and STM microcontrollers are like they're specifically designed for these applications. And one more platform is the ARM architecture. If you are looking for any high-speed data monitoring, or any high, if you want to read any high-speed data from sensors, so ARM architecture is for such applications. If you want to run multiple applications or multiple, if there is any software and hardware integration, any HMIs like human machine interface is there, or if you want to display some data on the screen, for those applications, you can use the Raspberry Pi or Banana Pi. So these are comes with the display where you can deploy different sensors and show the data on the screen. So like you can, it is like HMI. These are the processors. And when you go to, there are some system on chip. One more platform is called as system on chip, where you will write your own code. Application will be very specific. It is these controllers like STM or PIC, or you can write any code for any kind of sensors. But in the system on chip platform, you have to write the code for specific applications. Like maybe you consider a digital camera, where the purpose of camera is to capture the images for digital camera. So those SOC or PSOCs are designed to capture the image data and process it. They will not have any sensors, or I mean different sensors, or any different data coming, or any decision taking. All those capabilities will not be there for the this kind of special application embedded systems. Their purpose is to take the data, process it, and store it in the memory card.
Memory card. Okay.
And one more platform is FPGA. It is called as Field Program Gate Array. These kind of devices have a large level of applications, like your rocket systems, or CT scanning machines, or MRI machines, or
MRIs, yeah.
high-speed data processing devices uses FPGA. FPGAs are one thing is programming these FPGAs is are very difficult. Like expertise needed for is very high level of expertise are needed, and cost wise these are very expensive. And this kind of sophistication is not required for our day-to-day applications or industrial automations, or day-to-day application what we build at our office or in industrial environment. FPGAs are not required. FPGAs are very specific, very different kind of applications we can build.
Application.
Yes, yes.
Wonderful. Very well explained. And tell us about your company, um, capabilities, please, for our
Uh,
audience.
we can build the applications using like present. We started with the academic projects. Now we are building industrial projects. We can build the IoT system, remote monitoring devices. We mainly work on embedded system with respect to industrial automations. We don't work on SOC or FPGAs. We have the capability of building embedded systems for industrial automations, maybe IoT, IIoT, remote monitoring devices, sensor integrations,
Very nice.
kind of systems we can build, or
Excellent.
automatic means.
Yeah. So for the audience purpose, GIPZONICS.com is the website. You can go and check all the details about the company. Mr. Vinay Hegde is the co-founder of the company. Vinay, we are almost now coming to the end of the show. Uh, it was so interesting to listen to you about so much of this technically driven subject. And any last couple of minutes you want to give any message to our audience?
In any kind of development, there are three things. It's like a pyramid. Uh, Here, one point is cost, another thing is development time, and third point is performance. So user can choose only two. If you want to save the cost, then development time will be more and performance will be lesser. If you want to save the time, the cost will be more and the performance will be less. If you want to choose performance, then cost will be high and development time will be low. So this is what I want to convey to the all the viewers.
Very nice, very nice. It's a very interesting message, Vinay. And thank you once again for joining today's talk show. And I think the audience, I'm pretty sure they liked it. And you are free to comment on the comment section. And also, please do subscribe our channel. As I mentioned, the more the merrier. The more subscribers means more viewers. More viewers means our guest will be happy and we will be happy. And we will bring you every week some interesting topic about electronics manufacturing. With that said, your host Rajiv Kulkarni will sign off for one more episode of Global Electronics Talk Show, the Friday Talk Show, and we will come back again next Friday with yet another guest and with an interesting topic on the process. And standard operating procedures and process and all those fine details. Till then, take care of yourself and take care of your health. And thank you very much, Vinay, again, and have a great evening. Have a good weekend as well. Thank
Thanks,
you.
Rajiv. Thank you so much for hosting me here. Thank you.
Sure. Thank you. Thank you very
Okay.
much. Yeah. Bye.